In this section, I want to talk a little bit about taking our geometry. We've got a detailed model here. In this case, you can see that I have implemented two stress relief, one over here, and then also a smaller one at this step right here. And so I want to simplify and cut away the stuff that I don't need. So the approach I'm going to take, you could do a variety of things, is I'm going to put a plane there and also define a plane here. And then I want to offset those, and so the easy way I know how to do that is I'm going to make a pattern with two elements, and we'll want to move it along that axis, and I can offset that enough that it's more than a diameter. Looks good to me. So I'll hit go, and then I can offset my other plane. That's a larger diameter and most of the features behind it, so that's going to take more distance. Let's see if 80 looks right. Oh, I got to select my axis. I want to offset this direction. Yeah, it looks reasonable. So we'll go with that. So now I've got my solid here. Let's see if we can split the body. So we'll select that and we'll split. And that's gone. So let's pick start over again. Let's pick our body. We pick the body, pick the cutter. And we're going to get rid of this. Okay, what didn't I like about that? Okay, looks like I've already split my body, so I can't split it again. What I can do, and I don't mind keeping that, but what I want to do is I'm going to suppress it for physics. And I'll also just hide it there. So we have just the part that we need in the model. Now, in this case, I want to keep all the details in there so that we can account, those can all be accounted for. Now, an alternative approach, if you're going to try the different geometries, in particular, would be to do the splitting, the cutting in the SolidWorks, make that a configuration in the SolidWorks. You could export that as, for example, a step file, and then import it into SpaceClaim. And then that way, when you update it, you may be lucky in that all of the references you could change the geometry, and with a little luck, you may not have to redefine your model in Workbench. So once we have that model, we can come back to here. Let's open Ansys Mechanical, where we'll be able to set up the boundary conditions for this model. So now we have the model imported into Ansys Mechanical. In order to do the submodeling, what we're going to need to do is take the solution and wire that to the setup of the new model. And I'm going to update the components. Right, and so I can see the question marks. So there's some things that I need to address in here. And so you notice it creates a submodeling group in there. So now we want to put our cut boundary constraints. So we'll identify our cut boundaries and apply. Let's go ahead and insert another cut boundary, since this one, I didn't select both of them the first time. So now it's going to find the deflections from the beam model and apply those on this face so that it will have the equivalent stresses. Now I still need to make sure that I have other loads because I had because we had loads placed in this area of the submodel. I need to go ahead and apply them in here as well. So I need to stop the shaft from spinning to resolve the torque. And so let's apply. So we'll put some displacement. We'll select face of the keyway, apply, and then I want to keep it from rotating, so I'm going to just keep it moving from normal to the Y direction. I will note here that I can pull these from, pull out the submodeling results for particular steps in the model, which we can explore a little bit later. If I look back at my B model, I have forces in the Y direction, and so I need to go apply similar forces in the on the shaft in my detailed model. So let's switch over to the other mechanical. And so I need to put a force there. And ideally, I'd probably split this face and apply it on that face, but I'm going to go ahead and apply this to the whole area. So, and I want to do, let's see, we're going to insert the force. And I'm going to do that as a bearing load so that it gets it somewhat more realistic distribution around there. And we'll define that based on the components, so in the Y direction, and we'd need to match what we did in the other one, but I'm going to say minus 100 newtons here. Okay? And you could choose appropriate values that you use in your simulation. With that set, then we can begin to run this. Let's insert a few, a little bit of a couple solutions, and let's see if it works just by hitting a quick solve. Okay, so I solved the load case, and we could see, for example, this is distributing pressure across that whole area, which I really wouldn't want to do, and we're giving some unrealistic stresses there in that corner that I'd either need to resolve or change the way I'm applying my load, or I would need to put a, otherwise exclude that from my analysis, because that's not really the case that I'm concerned about. And then obviously the other part is this mesh is way too coarse. I mean, the whole idea here is to be able to use a refined mesh. And so my next steps would be to come in here and insert some sizing and other mesh controls so that I could get finer features in the regions of interest. One of those is going to be the fillet. And let's go. It's about 1.5 millimeters. And the other one that I'm going to want to do is this other fillet. So let's insert a new mesh control. Apply that and start out with 1 millimeter. And we also probably just want to change the overall size of the mesh. Right. And then I can generate it, and I can progressively refine this as we go. So let's generate the mesh and see how that looks. So for this case, where I'm showing two different refinement methods or stress relief methods in these two cases, I went ahead and I also added a refinement onto those fillets, and that does a nice job of spreading that out and the fine mesh around that area. Maybe a little extra on the outside here, more than I need, but you know, it's not too bad. Now with this and having both of these features in the larger meshed area necessary, because of that, the model's a little slow. It's going to take a little bit to solve. So I'm going to explore the rest of the stuff without those refinements, which is always good practice when you're setting up your model and making sure things are working right, and then do a nice coarse model initially so that you see that everything makes sense on your boundary conditions, and then you can refine it and collect the data and, you know, do your mesh convergence and things that you may need to do. We observe when we look at the solved mesh, everything looks blue, and that doesn't seem very realistic. And as we look around, we can use advantage of doing the probe for the max. We look around and say, yeah, interestingly, we've got most of the stress right here, which kind of makes sense because I have not put in any fillets, so that's going to be a high stress state, but it's also away from the areas I'm interested in, and so I'd like to just ignore that. And so what I'm going to do here is just change this cutoff here so that we begin to reduce some stress. That's not quite enough, so let me adjust that down to and so now I'm getting a more interesting contour here. I can see the stress. Now this deformation on the top, again, for your analysis, if you were to see something like that, I would expect you to split the face so that you could just apply the load over a smaller area so it's more realistic. But with this, we've got, it's also hard to see. And so one of the things I may want to do is just do true scale deformations so that I can see what's happening in those particular regions. Okay. So this shows you the basics process of solving for localized stresses using the submodeling. And the key was using the import cut boundary constraints in order to get the deformations that are applied at the ends of the beam. Because of that, because I applied displacements on these two cut boundaries, the model was fully constrained, and I did not need to apply other displacement constraints in the model, at least in this case.